Let's sum up confidence intervals with the formula and the definition. The formula we saw from a previous video, we were going to take, in our case, our sample proportion, or p hat, and then we are going to add and subtract, so that's plus or minus, our critical value. In this case, it's a z-score, a very certain z-score that gives us 95% in the middle of the bell curve, and then our standard deviation, which we had calculated. Just from our research, we got a point estimate. That is our sample proportion. And we could just say, well, according to our research, it's 62%. But to give it a little more strength, to give people an idea of how accurate our research has been, we're going to plus and minus this number, which is called the margin of error. If we take that 1.96, multiply it by the 0.092, and we got, 0.02 something, and we got something like 048. This is the margin of error, often just abbreviated as E. So let's write that down, a little picture of what our research was trying to capture. Somewhere between 0 and 100%, we came up with a point estimate of 62%. Then we bring the statistics in and say, well, from what we know about sampling probabilities, I can tell you that 95% of the time, our samples are going to be in between these numbers. And if we round that to 5%, then that makes this kind of easier to write in. This is, down here 57%, and up here 67%. So that's 62% plus or minus 5%. Now, where did we get these values? They came from the normal distribution. This z-score of 1.96 was our critical value. 1.96 times the standard deviation gave us that approximately 3% to the right. And then subtracting the 1.96 times standard deviation gave us approximately 3% to the left. Now, what does this mean? 95% in the middle. 95%. Basically, I need to teach you what not to say. Okay, so up here we have our definition, and this is what we're supposed to say. That the confidence level is the probability that the interval, and that's what we're talking about, our interval, how good is it? It's the thing in question. It's the thing that moves. Do we have it too wide? Do we have it too narrow? Is it even off center? Well, we, because of our sampling technique, because of what we know about central limit theorem, we can say this, that our interval will capture the truth, the true parameter, in repeated sampling or with repeated samples 95% of the time. There's a 95% chance that our interval is going to capture the truth. Here's what we don't say, okay? We don't say, it's very tempting to say, well, now that we've got this set up, let the truth fall, like we've just rolled the dice or something. Well, that's not accurate, okay? Never ever say this, and we're just going to circle it and then cross it out. The true mean is not falling anywhere, okay? Think of the true mean as a post anchored in concrete. It's already out there somewhere. And it's our frame here, our interval, where we're trying to focus like a camera or trying to center it, maybe like the sights on a rifle. We're trying to take aim at the truth. And do we have it right? Well, we have a 95% confidence that this interval has captured that concrete truth out there somewhere. It might be 58%, and this is where the idea of randomly falling somewhere is going to is it 64%? Is it 50? Is it 58%? Is it 61%. I'm drawing these dots in here. Well, no, it's not falling there. We may, if we were lucky, have someone reveal the population truth to us, but in most cases, we'll never know the true parameter. Statisticians go around in a world of probablys. Right? This is what I think it is. And a pollster for a politician would be doing the same kind of thing. We think 62% of people are going to vote for you in the upcoming election, plus or minus 3%. And you have to take that with, for what it is. It's the math is behind it that tells me probably at least 57% of people are going to vote for me. And if the sampling is done right and the data has been collected well, then polling seems like magic and it works. So that's confidence intervals. Let's try a few examples in the homework.